So this is section 2.3 of the guided notes, and we've learned how to graph absolute value functions, and then we've also learned how to solve them algebraically. And this is just an extension where this is solving things for absolute value inequalities. And so you know that when you solve an absolute value equation, it's possible to get two solutions. So we're going to explore what happens when you solve the inequalities. So now determine whether each of the integers from -5 to 5 is the solution of the inequality. So basically, you're going to plug in, and this is a lot like some of the warm-ups you've been doing, where here's our problem. We've got essentially the absolute value of x plus 2, and then we need to find out if that's less than 5. So I'm going to replace for x various values and then use the integer values to see, well, what works. So when x is -5, well, what is the absolute value of -5? And that's, of course, 5. And is basically this plus that, 5 plus 2, is it less than 5? And the answer is, well, no, it's not. So what about the absolute value of -4 plus 2? Is that less than 5? Basically, are these true? Is this one true? We already found out that this was a no. So this becomes 4 plus 2, and that would make 6. Is 6 less than 5? No. What about -3? Right, is the absolute value of -3 less than 5? Is this true? And you get 3. 3 plus 2 is 5. No, that's also not less than 5. But you'll notice, right, when I get to the absolute value of -2 plus 2, right, I'm going to do some more work over here. Is that less than 5? Well, it's true. That is true. That would be less than 5. And you can keep working these out, right? And that's less than 5. And 0 plus 2, that's going to be less than 5. Well, 1 plus 2, that's going to be less than 5. And again, 2 plus 2, that's going to be less than 5. And when you get back to 3, right, you'll get, is 5 less than 5? Because you're going to get, by the time we get to 3, you have the absolute value of 3 plus 2. And then is that true? And no. So from there, it's no and no. So when it comes to which points work on this number line, right, that would just be, well, this integer works, this integer works, that integer works, that integer works, that integer works. Oh, and I 3 is the one that doesn't work, and that integer works. So in essence, you could say the solution to this one would be like, well, it looks like x is going to be between I'm not going to use the equal symbol. I'm going to use looks like x is going to be between 3 and -3 approximately. But no, probably 2.5 doesn't. No, 2.5 works. Yeah, just when you get exactly to 3, it doesn't work. So let's take a look at the next example. Give you a moment there to get this down on your notes. I'm going to move on to the next one. So here we go. Let's try this scenario. All right, you've got essentially the absolute value of x plus 2 greater than 5. So now let's plug in our various values of x, and we'll start off. Is negative 2, or negative 5 I should say, the absolute value of which plus 2 greater than 5. Is this true? Well, that becomes 5 plus 2, and that makes 7. So 7 is definitely bigger than 5. So yes, that's true. And negative 5 would be a solution to this. What about negative 4? Well, that's going to be 4 plus 2. Is 4 plus 2 bigger than 5? And the answer is, well, yes. How about negative 3? Is that bigger than 5? And right here we're going to get a no. So it's you can keep plugging in values, and you're going to find that the next few are no, and no, and no, and no, and it almost follows a symmetrical pattern as the other one. And you have to go all the way to here before they're yes again. Right, so for instance, the absolute value of 3 plus 2, that is not bigger than 5. But this next one certainly is. So it's like this is true. And if you're thinking those are 7s, that's the greater than symbol. Let me clarify that for you. Greater than symbol, the greater than symbol, greater than symbol. Right, and this is also true. So, the answer to this, if I were to write this as an inequality, would probably look something like, x is going to be less than negative 4 or equal to, right? Because negative 4 also worked, didn't it? And, or x is going to be greater than or equal to 4. You know what? That's actually not correct. It's the opposite. Now that I think about it a little longer, it's not this. It would be, well, x has to be less than negative 3, or x has to be greater than 3. So that would be the correct way to indicate that as an inequality. So now let's take a look at this next example. Oh, and actually this just has having us graph these on the number line. So you'll recall, right, the three themselves were like excluded from the answer. But then on a number line, so that's going to look like basically this. Or, if you will, open circles from negative 3 to 3. And conversely, the opposite of that, which was this second example we did, does this. And this is when that poster, the inequality review, is going to come in handy, right? Because this is just kind of sort of a refresher from Chapter 2 of Math 1, with the exception that now you're working with stuff with absolute value. But the inequality rules are all still apply. So I'll give you a moment, and then we'll go to the next part of the notes. So in this next example, you could definitely use Desmos to help you out, right? And you could, at least if you just wanted to get the two lines, you could set this equal to 1, and you could set this other one equal to the absolute value of x minus 2 minus 3. And you're going to wind up with this horizontal line. And then the other graph is going to be, well, to the right 2 and down 3. Something like this. And then from here, something like that. And right, there's going to be an intersection here. There's an intersection there. And really the only thing when you graph these is, theoretically though, these things are not equal, right? I just use the equal sign to help me get the two graphs in Desmos. But what you're really trying to find out is when y is less than 1, what are the answers that would apply? So if you recall, horizontally, less than 1, that would be that the answers that lie below the graph of basically y equals 1. And the graph of this thing, f of x is equal to the absolute value of x minus 2 minus 3. Part of it at least lies below the graph of g of x equals 1. And the part of it that does is between the values x is equal to negative 2, right? And you can see that right there as I draw kind of a messed up arrow. And you can also see that there, right? That value is 6. So the solution of this is when, basically, when x is greater than negative 2, and when x is less than 6. Or in other words, something like that. So you can see, right, and that makes sense, right? Our answers on the graph are between these points, right? These points are negative 2 and 6, and here x is right between them. So basically any numbers between these two numbers will actually make this equation up here true. So these are the numbers that make the equation true. So as you're reading the next part of these notes, you'll notice the steps for solving absolute value inequalities are pretty much identical to the steps you would use when you were trying to make them equal to each other, or at least when you were using the equal sign, right? You're going to have basically a positive half that you're going to try to solve for, and a negative half you're going to try to solve for. And once you've done both halves, you'll probably wind up with one solution, two solutions, or no solutions. So let's see what happens in the following examples as we work through several. So this here, as you can see, I'm kind of using some of the resources from the textbook to help lay out these examples. But they have one there in example 2A that's been fully worked out. They've subtracted 15 from both sides, and they get 6, and then they basically divide their problem into two phases, right? A positive phase and a negative phase, and all they did was basically change either 6 or negative 6. So this is kind of exactly like the section 2.2, and again, they could have also used Desmos for example A, right, to give them the two lines. And if they did use Desmos, right, they would type in y equals the absolute value of 4 minus x plus 15. That would be one equation they would type into Desmos. And then the other one would be y is equal to 21. And then this would result in a graph. And let's see, where would the graph be? it would probably be shifted over here and up a bunch, and eventually you would get, a V with some intersection points, and they actually wind up with intersection points right at -2 and at 10. So now let's try B, for example. And it's got one kind of worked out a little bit. Right, they're gonna add 10 to both sides. And when they add 10 to both sides, you wind up getting the absolute value of x plus 4 is less than or equal to 8. So now I'm going to set up basically a positive and a negative version. Here's my one version. You'll notice though the sign, right? The sign on the second version, when they make this a -8, that's part of the rule. You gotta flip the sign around. And then you solve it like you solve every other algebra problem after you flip the signs and set up your two versions. Right, subtract 4 from both sides on this one, you get -12. Subtract 4 on this side, you get 4. So x is greater than or equal to -12, and x is less than or equal to 4. And what that looks like in a compound inequality is this, right? These are just two ways to write the same thing. And if I were representing this on the number line, you basically have a filled in circle because of that equals symbol right there, and a filled in circle here, and then you connect the dots, right? And all that's saying is x is between those two numbers, these two numbers, this equation is true. And you could test this for yourself. If I tried 5, for example, if I put 5 up here for x, 5 plus 4 is 9. Absolute value of 9 is 9. And 9 minus 10 is a -1. And -1 is in fact bigger than -2, not the other way around. So you would wind up with a false statement if you picked a number such as 5 that was outside of the solution set. So I hope that makes sense. Let's try a few more examples. So now I'm going to do this next example right here, but this tablet is super tiny to write on and much smaller than your piece of paper. So I'm going to actually take this work over to another page, but I do think the work on your piece of paper is going to be larger. So just follow along with me, and I have the problem written just as you see it in your packet right here, but I just now have a little more room to work with. So before I start with basically my two versions of the problem, I'm going to have to, get basically this x plus 4 all by itself with the inequality and some number. So I'm going to have to say like subtract 10 from both sides, and then whenever I do that, then I'll probably also have to divide by this 8 right here. So let me just start by subtracting 10. When I do that here, it's going to cancel. I'm going to get less than -8 here. And then I'm also going to divide by 8, both sides. Divide by 8. And when I do that, basically I'm going to wind up with the absolute value of x plus 4 is less than a -1. And hopefully this brings up the same alarm bells you had from the last section, and that the absolute value of something, right, can't be negative. So in this scenario, we're going to wind up where this is a no solution. So you, if you were to type these into Desmos, right, y is equal to 8 times the absolute value of x plus 4 plus 10, and you also typed in y is equal to 2, you would get basically a V and a line that never touch. And that's the same thing as no solution. And then there are no basic values of x where ultimately this thing is going to be less than 2. There's just no values for x that work. So that's what no solution means. But I also want to do a few more examples. Now, I know your notes packet kind of stopped short of this, and that's probably because I made the notes packet, I don't know, about a month ago, and I wasn't really working it out then. But I think we need to do a few more examples. So if you have more space in your packet somewhere, I'd like you to use that space, and let's just do another example or two, or you can even get out a sheet of paper. And then before we start our HRW, I just want to do a few more examples so we're more familiar with how to do these. So I'm going to try another one here, and let's just say I had x, the absolute value of x plus 11 minus 8, and let's say that's less than or equal to a -3. Now, right before I get started, I have to basically add 8 to both sides. And when I do that, I'm left with, let me change the colors here, I'm left with basically x plus 11, the absolute value of that, less than or equal to +5. So now I'm all ready here to solve my two versions. So one version is going to be x plus 11 is less than or equal to 5. And the other version is going to be the absolute value of x plus 11 is greater than or equal to a -5. Now everything's the same. The only thing that's different from 2.2 to this one is instead of equals, we're using inequalities. And using inequalities, when we are going from positive to negative, you have to flip the symbols. So hopefully if you have a sheet of paper you're following along, now I just solve these just like a regular algebra problem from here. I subtract 11 from both sides. I get x is less than or equal to -6. And over here, oh, and I got to make sure I got the symbol turned the correct way. Subtract 11 from both sides. X is greater than or equal to -16. And on a number line, that would look, let's see what that would look like on a number line. Let's say you had a number line here. And you would have -16 here, -6 there, and essentially x is between these two numbers. So anywhere between those two numbers is going to make this equation right here true. And written as an inequality, like a compound inequality, right? These are answers. Here's another way to write that same thing. -16 x, negative 6. Right? X is between them. So now we're going to go to the HRW assignments, and hopefully between this extra example and some more that you're going to see that this isn't much different than section 2.2.